So today we're going to review applications of quadratics. We've been looking at finding the vertex and the zeros and reading through a word problem and figuring out which one to use. So that's what we'll look at today. So first part, can you match the following? You want to find the highest or lowest point of the graph. How do you do it? Well, the easiest way, besides graphing, is to find opposite b over 2a to find the x value, and then you can plug that into your function and solve for y. If you want to find when something hits the ground, there's a few ways you could do it besides graphing. You could factor and use zero product property. You could also use quadratic formula where you set it equal to 0, find a, b, and c, and use it to find x at height 0 or so on. So let's do a few examples of using these to solve for different situations. So we can use quadratics to find the max price or the minimum cost of something. Many businesses will raise the prices of their goods or services to increase their profit. However, when they raise their prices, they usually lose customers. In such situations, the price at which the maximum profit occurs needs to be found. Here's the first example. An auditorium has seats for 1,200 people. I'm going to underline the important information here. For the past several days, the auditorium has been filled to capacity for each show. Tickets currently cost $5, and the owner wants to increase the ticket prices. He estimates that for each 50-cent increase in price, 100 fewer people will attend. What ticket price will maximize the profit? And so we can calculate this. We can say the revenue for a certain ticket price, I'll call it X. So it's $5, but if we're subtracting 50 cents per ticket, we're going to multiply that. So it's price times the number of people, so we have 1,200 minus 100x. I'm out of room, so I'm going to rewrite this smaller here. So again, revenue is cost of a ticket times how many people are going. So the revenue for x people would be $5, but then minus the 50 cents per ticket, times the number of people, which is about 1,200, but you would take away 100 people for every 50-cent increase in price. All right, so this is in factored form. We could use it to find the zeros, but we want to multiply this out so it's in standard form so that we can find the vertex. Okay, so to multiply it out, you could FOIL. I like using my box here. So here's my box. And we have 5 minus 0.5x. And here we have 1,200 minus 100x. All right, we're going to multiply this out. Black. So 5 times 1,200 is 6,000. 1,200 times negative 0.5 is negative 600. Oh, and this should be an increase in price. I'm sorry. So increase in price, this should be a plus. So $5 for every increase in price. So this should be a plus here, which make this a plus. We have 5 times negative 100x, so that's negative 500x. And then we have 0.5 times negative 100, so that would be negative 50x squared. All right, so now we can rewrite in standard form. So we're going to say revenue at a certain price equals, let's put our x squared first, so negative 50x squared. Combine like terms right here. So that would give us 100x. And then plus 6,000. All right, so let's use that to find when the revenue is at its maximum. So maximum is the vertex, right? So we'd have our function looking like this. We'd want the vertex. So to find the vertex, 2 steps. First, x equals opposite b over 2a. So opposite b would be negative 100 over 2 times negative 50, and so that would be $1. So if the ticket's $1, what would be the maximum daily revenue? So now let's plug in. So the maximum daily revenue, we're going to plug in to this function right here. So we'd say the revenue at $1 equals negative 50 times 1 squared plus 100 times 1 plus 6,000. Plug that in, and our revenue would be $6,050. So the revenue, if you charge $1 at its maximum, you would make $6,050 in revenue. So there's an example of using it to find what you could charge to make maximum revenue. We can also use a quadratic to find maximum height or when an object reaches the ground. So let's say Will jumps off a cliff into the water below. The height he travels can be represented by the function h of t equals negative 16t squared plus 16t plus 480. At what height did Will jump? And we know that at time 0, if these are zeros, the initial height would be 480 feet. That's the initial height. Okay, what will Will's height be after 1 second? So we just have to plug in a 1. And if we do that, we get 480 feet. So what happens is he starts, if I draw a picture of this, he starts at 480 feet, he jumps up and then down. So at 1 second, so here's at 1 second, he's at 480 feet again. What is the highest point that he reached? So the highest point would be the vertex, so it'd be before 1 second. So 2 steps. The first step would be opposite b over 2a. So opposite 16 over 2 times negative 16. And that would be at 1 second. And at 1 second, we're going to plug in. Oh, actually, no, it's not 1 second. I'm sorry. It's half a second, because we have negative 16 over negative 32, so that's half a second. And at half a second, the height, we're going to plug into our function. So we'd have negative 16 times 0.5 squared plus 16 times 0.5 plus 480. So you just plug into this function at half a second right here. And if we do that, here, we get 484 feet. So that's the maximum height that he jumps after half a second. How many seconds will it take for Will to hit the water? So if we're hitting the water, that's like at height 0, so we can use quadratic formula. All right, so we have x equals opposite b plus or minus the square root of b squared minus 4ac. And all of that over 2a. And so if we're plugging in, there's 3 numbers that I want. Negative 16 plus or minus. I want the discriminant. So if you type that whole thing in, you'll get 30,976 all over negative 32. And now when we type it in, we can get our 2 zeros, 2 real solutions. I'm kind of out of room here, so I'll put it here. And one is at negative 5 and one is at 6. So we're going to take our positive one, and we can say at 6 seconds, that's when Will hit the ground. Last example, example 2, but it's really example 3. Suppose Jerlies makes a dig that propels the ball to Rosalind with a height, or with an upward velocity of 25 feet per second. The function negative 16t squared plus 25t models the height of the ball at time t seconds. When will the ball ever reach a height of 10 feet? So if you look at this function right here, the c value is 0, which means she dug that out from basically the floor. So the height would be 0, the initial height. Will the ball ever reach a height of 10 feet? Okay, so let's, that would be the vertex. Will it ever reach a height, the highest value, the vertex? So that would be finding the vertex. So we have opposite b over 2a. So here the opposite b would be negative 25 over 2a. All right, negative 25 over negative 32, which is 0.78125. Okay, so this is the time when the ball reaches the highest point, but now we got to plug in to the original function. So h of 0.78125 equals negative 16 times that squared plus 25 times 0.78125. And when you do that, we get a height of 9.76563 feet. So will it ever reach a height of 10 feet? The answer will be no. The highest point it reaches the vertex is at 9.76563 feet. So on our assignment today, we'll practice these ideas of, okay, what are we looking for, the highest or lowest points, or we're trying to find the zeros, and then how would you go about solving that?